Hello everyone and welcome to this session. The title of the presentation is Another Cluster Bites the Dust, and that's just fine. And I think you understood that's a clear reference to the iconic song by the Queens, which is Another One Bites the Dust. And that's because today we are going to talk about how to sleep, how to shut down our entire infrastructure the right way. In this slide, there is already a spoiler about the tools we are going to use, which is Crossplane and kube-green. Why I'm here to talk about kube-green? Because one of my former colleagues, Davide Bianchi, is the father of the tool, is the creator of the tools. He was supposed to be with me here today to talk about this presentation, but he can't make to be here today, so I'm alone to present. Who am I? My name is Graziano Casto. I'm an Italian software engineer turned developer relation engineer in my platform. I know it's not an easy name. It's weird for Italian too. So if you find me around the hallway, just say, hey, I promise I can discuss with you. Don't worry. Anyway, I'm a developer relation engineer in Mia Platform. Mia Platform is an Italian company who built an inter-developer platform builder, and we have many open source projects like kube-green. Community-wise, I'm a tech lead for the CNCF tag developer experience, and I'm a Kubernetes contributor and a release team member for the upcoming 1.34 release, which is actually happening today. If you are interested in observability stuff or device management in Kubernetes, take a look to the release announcement that will be released later today. So, without any further presentation, let's start with the cool stuff. I would like to start by showing you this image. It's a simple dashboard of CPU usage, and the question is, do you see something wrong here? No, right? That's true. At the first look, nothing seems to be wrong. I mean, a few spikes, but that's usual and nothing to be scared about. But what if I show you the entire picture? On the left side here, you can see that the picture is basically the same. And on the overall time span, nothing changed in terms of how the pods, how the deployments are configured, and nothing changed in terms of how the cluster is configured. The only thing that changed is this green line separator. We added a simple Kubernetes separator on the cluster, which is kube-green. And as you can see, in specific time slots, which are the one highlighted in red, we had a huge drop of the resources used on the cluster. And why I'm showing you this image? That's because it's the starting idea for this talk. I want to show you how to shift and to have this kind of behavior from an application point of view, so just pods, to the entire infrastructure. Think about it. The picture drawn by the cloud, the premise that cloud give us is full of agility, scalability, and cost saving for the company. And that's actually true. Most of the time, we don't care about the hardware where our services are running. And we pay for the infrastructure with the pay-as-you-go model. And that's really amazing. But the truth is that managing cloud resources, infrastructure resources, is not like, it's not simple like buying fancy stuff on Amazon Marketplace. You can't just click 2 buttons on a web UI and have everything you need. If so, methodologies like platform engineering, for example, or tools for infrastructure as code doesn't exist. More, managing complex infrastructure in the whole software delivery lifecycle is tricky because we have the most important environment, which is our production environment, but then we need other replicas of this environment through the software development lifecycle for tests, for demos, for staging, for example. And the last point is that the pay-as-you-go model is amazing, but if we don't care enough about as we go, we could have problem in terms of cloud spending because of the hidden cost for the infrastructure where we are not using the services. Look at this picture. This is a simplified representation of how cloud infrastructure are managed normally into the software delivery lifecycle. You have many teams working on different products, and each of these products need many cloud resources, okay? You need a runtime layer. Just to keep things simple, I give you examples about AWS. So my runtime is an EKS cluster. Then I need storage. So S3, for example, I need the data, RDS, and I need any other cloud resources from the AWS cloud. But I don't just need them for the production, for the environment, for what the customers paid me to get my services. I need many replicas in the software delivery lifecycle. For testing, for staging, for demos, for showcasing new features to the customers. There is not a standard blueprint. Many companies use many different layouts in their software delivery cycle. And this brings many problems. Just to mention a few of them. First, managing manually the replicas of this environment is tricky and have a high risk of having drift between the configuration from production to staging to test, for example. And if our test environment, for example, is not aligned with the production one, the test we are doing on the test environment can be not valid, for example, can be flaky. Second one, usually we have more teams working, more people working on the same product, so we could have many features in test in the same time, and working on the same environment, we can have conflicts within the feature in test, and that's a huge problem because we usually don't want to have conflicts and slow down the productivity of the engineers. Last but not least, there is the environmental toil. We have the production cluster, which should and have to be available 24/7, but the other one, the testing, the staging, are only needed when the engineers are working. And for the infrastructure that is available and is used in idle, when the engineers are not working on this infrastructure, we are actually paying for that. About this last point, look at this picture that clearly represents the waste of leaving infrastructure alive when we are not using it. The example consider three environments. The production one, which is always available 24/7, so 168 hours per week, and the other one, which are supposed to be available just 40 hours per day, because you know we are supposed to work just 8 hours per day, right? But work-life balance is another topic for another talk, I think. That's clearly represent that we are wasting 256 hours per week, which is like 50% of our compute hour. We are paying for 50% more than needed. And that's not a problem just in terms of cloud spending. It's not a problem just when we receive the cloud bill. It's a problem in terms of environmental toil. It's a problem in terms of carbon emission. Because think about this data. We, the IT sector, the data centers, consume almost 1% of the entire electricity in the world. So I use the mantra in my life, which is the easier is to get something, in this case, the cloud resources, the more careful we have to be in how we use and manage these resources. To recap the problems, research demonstrates that on average, the CPU utilization for most of the server is between just 12 and 15%, leading to an average cloud spending waste of 30 to 45%. And that's just the FinOps facade of the medal. Using static environments like we are used to do will lead to many other overlooked problems, like the operational friction. So I'm an engineer in a dev team. I need a new cluster. I need new environment in general to run my application. Usually I need to talk with the operation team and wait them to give me the environment. Security concern or the trustability of the environment, using the same environment always in the SDLC makes it not aligned with the production one, and maybe the test I'm doing on the environment cannot be valid. And the last one, as I said, is the one related to the environment, to the carbon emission. So, what's the solution? How can we try to mitigate the problem? The solution is basically a shift from managing this kind of environment from a permanent and long-lived way to a more ephemeral and on-demand solution that allow us to first automate everything. We don't want friction between teams. We don't want to ask the developers to wait that other teams operate or do something to give them the environments they need. And we want to optimize the cost, both in terms of prices, in terms of cloud spending, and both in terms of carbon emission. So the solution is the ephemeral environments. What I mean with the ephemeral environments. Usually, our deployment, our SDLC workflow follow this step. First, developer want to deploy something for test. For example, they deploy their configuration for the deployment of the application on a repo, and we have some automation. It could be pipelines like GitLab CI or GitHub Action, whatever, or tools like Argo CD, for example, that takes this manifest and apply them on a cluster. Developers usually don't have nothing to deal with the cluster. It's something provided by the operation team. They just apply the configuration on the cluster. The ephemeral approach is quite different. Usually, we are not going to use pre-existing cluster because we want to avoid the previous problems. The advantages are, first, we want a solution that aligns with the platform engineering principles and is self-service for developers. So we don't want to need any other outside the team to enable the developers to create their environments. And the platform engineer's job here is to create simple and opinionated APIs to manage the infrastructure. Second, it should be something that is isolated by design and trusted, so it should be an exact copy, a perfect copy of the production configuration. And not to forget, we need something that acts as optimization layer into the solution to optimize the cost. To implement such a solution, we are going to use two different tools. The first one is Crossplane, which is the heart where all the automation happen. And the second one is kube-green, which is our optimization layer. Let's do a brief recap. What's the pro and cons of this solution? First, standard approach, which is the static environments. We said spending waste and configuration drift, but of course it's much easier to implement. We just need someone who for once create the cluster and then we use it. Using Crossplane, we are able to let the platform engineers create automation by exposing standard and opinionated APIs to the developers that they can use to create entire infrastructure components. I'm talking about infrastructure components, and in this case, I'm talking about clusters, but it can be anything. Databases, S3 buckets, anything you want. And last, we use kube-green for the resource optimization. Anyone knows something about Crossplane? What is it or how it works? Raise your hand. Okay. So, Crossplane is an open source tool. It's actually a framework to create control planes, and it turns a Kubernetes cluster into a universal control plane for infrastructure or managed resources in general. Okay. Crossplane lets the platform engineer to create those API and the users, the developers, to ask for infrastructure using the control plane using just familiar YAML files. We are going to see some example later. At the core of Crossplane, there is the concept of the provider, which is the first building block you are going to see when you learn Crossplane. Providers are a sort of, let me say, plugins that teaches Crossplane how to create and manage resources on a specific platforms. You can have, for example, the AWS family provider that have a lot of resources like Bucket, VPC, AKS, many others. Do you have the same thing for Azure? You have the same thing for GCP, Alibaba, and any other platform. Important to know is that you don't use Crossplane just to manage cloud resources on a cloud provider, but you can use it also inside the Kubernetes because it exists a Kubernetes provider that let you manage native or custom resources inside a Kubernetes cluster. Of course, creating in this case, an EKS cluster is not simple, just having a one-to-one map with a provider EKS resource. To have a production-ready cluster, we need many other resources, like all the networking layer with VPC, Internet Gateway, Subnet, and so on, and many other resources. So asking the developers to directly interact with the provider means that they have to use a chain of dozens of YAML in a precise order to get just a cluster. And that's not a feasible approach, and that's why Crossplane allow us to create custom and high-level abstraction API to bundle managed cloud resources as we prefer. The concepts here are the composite resource definition, or XRD, and the composition. Those together pack together many managed resources inside one or more provider and expose them with a simple API to the developers. What are XRD composition? XRD is like creating the front end or the user-facing layer for the infrastructure. With a XRD, you are going to define a new type of resources, like, I don't know, my company Kubernetes cluster, for example. And you are also defining the schema of the fields, the configuration fields that the developers can configure for the resources. A composition instead is the backend, the implementation that connects the XRD to the actual provider's resources, to the actual cloud provider resources, and bind the configuration that the developers use in the final API with the configuration available at the lowest level in the resources from the provider. So, what a developer needs to do when he wants to provision a new EKS cluster? Basically nothing, or I mean nothing after just applying the claim. The claim is what the developers use to provision the infrastructure. Here on the screen is an example of a claim to provision an EKS cluster, and as you can see, the API is configured to let the developer just configure the region where they want the cluster, in this case EU Central 1 in Germany, and how many nodes they want to have. The other stuff is managed behind the scene by the XRD and composition that the platform engineers did once, and basically developers can provision using this API how many clusters as the company can pay, probably. The best thing here is that you are using Kubernetes as a control plane to provision your infrastructure, and so you can leverage the reconciliation loop of Kubernetes to ensure that your infrastructure actually keep the desired states. What I mean is that if I provision this deploy target TKS using Crossplane, and then someone who has access on the AWS console changes, for example, the node count from 3 to 4, it can be restored to the original state automatically. The second tool is kube-green. Kube-green is much simpler. It's just a Kubernetes operator, and is basically born for reduce the carbon emission of the Kubernetes native resources. It exposes a simple CRD, which is called sleep info. That's an example, an exhaustive example. And to configure kube-green, you just need a cert manager on the cluster, the operator installed, and you can first sleep info just by defining a sleep path and wake up that at timing, which are those used to sleep the resources by scaling down the replica set of the deployment, a time zone for the time, and the target where you want to kube-green to act. And that's the standard behavior of kube-green. From the latest releases, we introduced the patch mechanism, which is suitable, which allow kube-green to interact with any Kubernetes resources. You can define patch to edit any fields in any Kubernetes resources. Also, CRD. In this case, you can see sleep info with a patch defined to edit the node count of our Kubernetes claim, defined with Crossplane. Let's see a sort of reference architecture or sequence diagram of how we can manage and create automatically ephemeral environments. First, we need a trigger for the flow. The trigger could be, this is just an example, you can use any trigger, like someone who opened up here on a repo to test a specific feature, or you can decide to use as a trigger, for example, a tag on a branch or any other Git level trigger. Or if you want to keep the thing simple at the beginning, you can also don't use a trigger and let the developer apply manually the claim on the cluster. And what happened? Pipeline commit on an infra repo an AKS claim, which is an example we saw before, and the sleep info. The sleep info here is exactly this one. These are the two files that are applied, the claim and the sleep info that act on the claim. Then, once the two YAML manifests are available on the repo, a tool following our GitOps standards like Argo CD takes the manifest and apply them on the management cluster. Important to note here is that the management cluster is not where the application are going to run. It's just where Crossplane lives and running. On the management cluster, the platform engineers are created and installed the XRD decomposition. And kube-green is available to manage the sleep info we defined. Once we applied the sleep info and the claim on the cluster, the provisioning happens. It's something that takes like from 50 to 20 minutes, and that's why I'm not doing a live demo today. Anyway, when the provisioning ends, as you can see here, you can get the AKS cluster kubeconfig directly from a secret inside the management cluster to allow the developer to enter through kubectl into the new provisioned cluster. The AKS cluster is there, we can access, and we can apply our application manifest and start testing the application. That's an example. I use the PR as a trigger, and I have as an outcome a new cluster. Maybe you are not in a large-scale enterprise, and maybe you don't need a cluster per PR as a separation layer. You can decide to have a cluster that is destroyed and recreated, for example, each release. Every time you have a new tag on the main branch, for example, and use the Crossplane for each PR to create a new namespace, and so using namespaces as a separation layer on the cluster. I want to make you notice that we have kube-green both on the management cluster and on the AKS cluster, our runtime for the application. That's why we apply the optimization in both levels, both on the application level and infrastructure level. How? First, kube-green on the management cluster acts on the Crossplane claim, the claim for the cluster, and scale the node groups from 3, as the example, to 1, just to keep the cluster healthy. We just leave one node. And the kube-green on the EKS cluster acts on the deployments, scaling down the replica set for the deployment to 0 at specific time. How the optimization flow works? On specific time, so during nights or during weekends, first act the kube-green on the EKS cluster and scale down the deployments replica set for the application and keeps in a secret the original state of the replicas. Once the deployments are with 0 replicas, kube-green on the management cluster scale down the node pool to just one node for the EKS cluster, and then during mornings or during Mondays, what happens is, on the contrary, the first to act is kube-green on the management cluster that wake up the other 2 nodes of the cluster, and kube-green on the EKS cluster restore the original state for our application, so that developers basically find the workspace as the same way they left the day before. What happens when the PR is closed? Basically, it's simple, because we close the PR, the pipeline is triggered, the AKS claim and the sleep info are removed from the Git repo. Argo CD remove the resources from the management cluster, and Crossplane handle the disposal of the EKS cluster. So basically, the resources are completely released. How the optimization model works, we have 2 different layers. The first one, we can call it macro optimization or operational optimization, which is provided by Crossplane, that allow us first to automate everything. We don't have friction between teams. We don't have developers who wait for operation team to create the infrastructure. And this optimization layer, in the example I showed you, allow us to have a cluster for a specific PR, so no conflicts between feature in test, and have these resources allocated only for the few days we need them. The other optimization level provided by kube-green, which is, we can call it resource optimization or micro-optimization, allow us that in the short time span of the days we need the cluster, we use the resources just in the hours when we need them. So from Monday to Friday, from 8 a.m. to 7 p.m., let's say. Let's try to give you some numbers. That's an example using a small cluster on EKS composed by 3 nodes of kind T3 small. Why this node kind? Because they are the one available with the free tier of the AWS. And the cost per hour of each node is 0.024 US dollar per hour. Here all the maths on the right, but using the standard approach, we have a cost for cluster, considering a week from of 8 days from Wednesday to Wednesday, just to have the weekend in the middle. The cluster cost 13,824 US dollar. Using the proposed approach with especially kube-green that scale down the nodes, we cut the cost by 50%. So the cost now is just less than $7 US. Things make interesting where we are coming to the carbon dioxide emission cost, and the calculation here is a little bit more difficult, but we can access how energy the hardware consume just by considering the virtual CPU of the nodes. In this case, we have 2 virtual CPU per nodes, and we know that each T3 small node have a power of 4.24 watts. To know exactly how energy they consume in a week, we can multiply this number for the hours the nodes are available. In the standard approach, if I don't remember wrong, is 575, and in the ephemeral approach is just 288. That's because each node is considered for the whole week. And we have basically the power they consume, which is for the standard approach 2.772 kilowatts per hour. And to know exactly how many carbon is emitted using this infrastructure, these machines, these servers, we have to multiply this number, so the power used by our infrastructure by the carbon intensity factor. What is carbon intensity factor? Is a grid-related number which tell us how many carbon is emitted in the atmosphere for kilowatt hours. Okay. How you can access this number? There are out there many services like Electricity Map or what's the other? Uptime, that show you real-time values for different grids in Europe or all over the world. If we have time, when I finish the presentation, I'll show you something about that. And what's happened here? For the time span, 8 days, we have 50% less carbon emitted in the environment using the proposed approach. We are shifting from less than a kilogram in a week to less than 500 grams in a week. Now, let's do a projection of the cost for the entire month. I don't want to make you see the absolute number, because it's simply a multiplication for the days. But I want you to make you notice how the usage of kube-green is reflected on the progression of the cost in the chart. As you can see, the red one is the static environment approach. It follows a linear progression, so the cost increased by a factor each day. On the other scenario, the green one, you can see some flat spots, the one highlighted in red, and those are where kube-green acts. The most evident one are these four, which are exactly the weekends, where all the pods are basically stopped. And as you can see, on the weekdays, we have less compute in the whole day, and that's why the red line is higher than the green line. And this one is the projection for the carbon emission cost. That's basically the same chart of the previous one, but I want you see how many kilograms of carbon we can save using the approach, which are 1.63. And okay, number probably doesn't mean nothing to you, but is the equivalent of driving for 14 kilometers a modern car, or keep for 3 days a 50-inch LED television for the whole time for 3 days, and is the equivalent of the carbon that a single tree can absorb in one entire year. So just by using a simple operator without changing nothing in terms of application architecture, how we provision the infrastructure, we can basically in a month save the carbon absorbed by a single tree. Now, I basically ended the presentation. I will show you the tools to get the carbon intensity now, but I said I didn't make a live demo, because to provision an EKS cluster I need more than 20 minutes just for that. But I prepared a guided workshop to learn how to use both kube-green and Crossplane in a combo. This is a guided workshop that ends with the provisioning of an EKS cluster, but is composed in many different layers. The first one is local first, and you can experience with kube-green and Crossplane by manage a cloud native PG Postgres cluster using everything inside your kind cluster. Then there is an example of how to manage S3 buckets, and of course, S3 buckets cannot be shut down, but the example is how to enforce more restrictive policies using kube-green. And the last one is the AKS example I showed you in the slides today. Okay, let's see if I can show you the electricity map. You can't see me now, okay. This one is the tool I mentioned later. This is electricity map. Basically, you can access the web UI, or the service is available as a API. I made a talk which is available on my website, where we are using it to get carbon intensity data and balance the scheduling of Kubernetes workloads using KEDA. So we are using these metrics as scheduling thresholds. And you can see that we can get the carbon intensity for each country in the world. For example, this is France, and we have a carbon intensity factor of 26 grams per kilowatt hour. And you can also see all the sources that feed the electricity grid in this country. In fact, the carbon intensity is not a standard number, which is the same the whole year, for example. It changed during the day. It changed based on which resources are used to create the electricity. In this case, for example, is quite low because they use a lot the nuclear energy. If we go here on Germany, where the EU Central 1 cluster is located now, is 480 grams. In my example was 311 because of the day I took data. Maybe they used a lot of wind and solar energy. The weather conditions were different, so the carbon intensity factor was different. This is the workshop repository from the slides I showed you previously. And just to give you an example, this is what, where is it, APIs, no, claims. This is the example, the manifest the developers have to apply on management cluster to get the EKS cluster. So basically 15 YAML lines. This is what the platform engineers built on top to let them to access the cluster. This is quite a complex composition because it's a nested one, because we have a composition for the compute where I manage the cluster and the nodes, and another composition for the networking layer, VPC, subnet, and so on, and on a higher level one where I aggregated both of them. And you can access the file here to read the manifest itself, or for each cases you have a guided workshop, for example EKS, where I explain everything from prepare the workspace to actual check what happened behind the scenes when you are applying your claims or you are applying your sleep info. I finished the presentation. We have a couple of minutes. If you have any question, I leave here the QR code if you need to scan it. If you don't want to give me to ask me any question, I will be in the hallway track for the next 5 hours, maybe. So I will give you the mic.
So thank you for the presentation. I just have a question. When you reduce the number of nodes for the cluster, are you sure that the application is still running?
That's what I showed here. Where is it? No. Here. Before sleeping the node of the cluster, we are using kube-green to shut down the replica set of the application, so that we are reducing the risk of terminating the nodes where the application is still up and running.
Okay, thank you.
Does not kube-green, the another tool, the cross, does this tool also understands kube-bird? I mean, can you provision a cluster of clusters, so to speak?
It's not a responsibility of kube-green, I think, but it's more about it's more about a feature of Crossplane, because the automation is handled by Crossplane. I actually don't know, but I'll show you. If you go to the Upbound marketplace, this one, you have basically, it doesn't exist, common exist. Okay, there is a marketplace. I will share with you the correct link, where you can find all the providers for anything, basically. If you find a provider that suits your need, you can basically create your abstract APIs based on the provider. If the tool you want to manage is something that is deployed inside Kubernetes as an operator or as a CRD, you can use the standard Kubernetes provider to manage the Kubernetes behavior with Crossplane. And that's showcased in the first case of the workshop, where I use Crossplane to create and destroy the cloud native PG cluster Postgres, which is a Postgres managed by a Kubernetes operator. Any other question?
Yeah. So my question is, how is kube-green different from Kida, or like why would I choose kube-green over Kida?
Kida is an autoscaler, okay? So first you need to define thresholds, and to define thresholds you need data. I did a talk on how to use Kida to scale the cluster behavior based on carbon intensity, and is much more complex. And here with kube-green, we are applying simple CRD just to shut down the workloads where we are sure that we don't need them. Think about it. If I create a rule for Kida that scale down the deployments to just one for the application, when the carbon intensity is higher than 50 grams per kilowatt hours, and I did it on something critical, and the workload is time sensitive, I probably have issues on the application side. It's much simpler to do it and be sure that nothing goes wrong using kube-green, because we are doing it when we are sure that no one is using the application.
But as far as I know, with Kida, you can also have cron schedules, so you don't always need data.
Yeah, I was not aware about the cron, but yeah. Any other question?
Yeah, thank you for talk. I was wondering, you mentioned that it's not necessary to build full-fledged clusters. We can do with namespaces.
Yeah.
It's very close to me. Will we be able just to skip the node management and just stick with the replica set changes every night and just let the node scaler of the cluster do the rest?
Yeah.
Oh.
That's the standard behavior of kube-green, because it was born with the native support of Kubernetes native resources, which are deployments. And if you want to create namespaces on an automated basis, you can use the Kubernetes provider of Crossplane to do that. Okay. Or you can do it by manually. Yeah, another question, but we are out of time, I think. So if you have any question which is quick, I can answer. Otherwise, I can answer on the hallway.
I'm doing my best. Just a quick question. When it comes to preview environment, have you a recommendation how to synchronize data from, say, a production system to the test system, especially when it comes to databases? Okay. Actually, it's not a quick answer. This one. We can talk about that in the hallway, because I don't want to be of obstacle for the next speaker. So I'll remove the PC from the setup, and we can discuss about that. Thank you very much.